Hey everybody, welcome to today's video where we're going to be focusing on how to match an inequality to a real life scenario. What I mean by matching an inequality to a real life scenario is actually kind of down here where we have a problem and then we've got multiple choice options for matching those. So that's what I mean by matching. And to kind of lay the groundwork early on up here to just get comfortable with some vocabulary, I'm actually going to write a few of the inequalities with you and then eventually we're going to just have to worry about matching them, okay? So for this first one here, we have that your age, which you guys know this, your age must be at least 18 to vote. So if I use an A for our age and then an 18 for the age, we're saying that you can be at least 18 to vote. Now, if you're at least 18, that means you're older than or equal to 18. So that's what I mean by we now have an inequality to kind of match this scenario. All right, for the next one, a budget for an event is set to be no more than $400. So let's let X be the amount of money that you can spend, and 400 here is the maximum for our budget because we can spend no more than that, which means we can spend less than or equal to the 400. So X is less than or equal to the 400 if it's no more than 400. All right, a minimum of 4 people are needed to play a board game. So we need 4 or more people to play the board game. So if X is the number of people we need more than or equal to 4 people to be able to play that board game. And for the last one here, the ages of the students who attend Irving are between 11 and 14. Now we've seen one kind of like this before with in between, and so I'll show you guys now that we know that the age of the student is older than or equal to 11. But also less than or equal to 14. And that's how we can show in between 11 and 14, with X being greater than or equal to the 11, but less than or equal to the 14. All right. So now, since we've already covered Unit 4 equations, and now we're in Unit 5 with inequalities, let's kind of just read through these 3 scenarios and decide, would it be an old Unit 4 problem, or is it like now an inequality problem? Okay. So for this first one, it will cost Sarah $46.88 for each day that she wants to attend a particular theme park. If she has $600 to spend, what is the maximum number of days that she can go to the park? So basically, because we have a maximum, she can spend 600 or less. That gives us an inequality. And off to the side, I'm just going to write it here, that if it's 46.88 times the number of days that she's there, that would need to be less than or equal to the $600 budget that she has. So again, an inequality. All right, if Andrew charges $35 every time he cuts a customer's lawn, we want to know how many times will he need to cut a lawn if he wishes to make at least $850 tomorrow. So again, this one's going to be an inequality because of the words at least. And we know that he's going to make $35 for each lawn that he mows. And we want that to earn at least $850. So we're going to show that the amount of money that he earns has to be more than or equal to the $850. So this is, again, another inequality scenario. Now we have another problem here that says Tamara spent $38 on a taxi ride. The taxi company charges $2.15 as a flat fee. Basically, when you get into the cab, there's already that money on the monitor. And then they're going to charge 85 cents per mile. How many miles was her trip? So see, this time, y'all, it told us that she spent 38. So we know that she spent a total of $38, and that's going to be an equation setup. And if it's $2.15, whoops, let me put a 15 here, $2.15 plus the 85 cents per mile, when we solve this equation, we will know how many miles the trip was. So again, that's kind of the difference here. You're looking for keywords like what's the maximum or minimum, at least or at most. If you want to spend no more than something, minimums, between, those are all going to be inequality setups. And if you're given an actual total, kind of like we were in Unit 4, that's back to when it's an equation. So kind of practicing with that right here, Maria wants to buy a new winter jacket that costs $150. So we have a total of equaling $150. So this is going to be an equation setup. Maria already has saved $50 and she plans to save $25 per month. So we know that she's going to put away $25 per month and she's already saved the $50, and that is going to be how she gets the total of $150 to pay for the jacket. So which of the following equations could represent Maria's savings for M months, if that's the number of months right there? And we already found it right here. This is B. $25 per month plus the 50 she's already saved to equal the 150 for the jacket. Now, if we actually solve this equation by subtracting the 50 that she's already saved, then we know that she has only $100 left over that she's got to save. And if she's saving 25 per month, we know that she's going to need to save for 4 months. And in 4 months, she'll have enough money to be able to buy the jacket. All right, for number 3, Blair's suitcase has to weigh no more than 50 pounds to fly. Blair's suitcase has to weigh no more than 50 pounds to fly. So if something's no more than 50, it has to be less than or equal to the 50 pounds. And already when I look at my answer choices, I can knock out answer choice A because we're looking for less than or equal to 50. B has it. C says the weight would be greater than 50. D says the weight is less than 50, but it doesn't have the or equal to because it could equal 50 pounds. So even just on that one statement, I have to narrow it down to answer choice B. But let's double check the rest of the scenario. So the empty suitcase itself is already 8 pounds. So that's why there's an 8 here. So the suitcase itself weighing 8 pounds plus whatever Blair is going to pack has to be less than or equal to 50 pounds total. And that's why the answer choice here is B. Notice that this one is an inequality because Blair's suitcase can weigh no more than 50 pounds. So as long as it's less than 50, she's good to go. And that makes it an inequality with lots of possible different answers. Whereas up here for Maria, Maria would have to save for exactly 4 months to be able to buy it. Now she could save for longer than 4 months and just never buy the jacket, but it doesn't say anything about that up here. It's assuming she's actually going to buy the jacket. All right, cool. Now let's flip over. So for number 4 here, we're talking about a bodybuilder, and we have that a bodybuilder can bench 225 pounds. So just think about a barbell and just think about the weights on the ends. And so what we have here is that the bar itself, the bar already weighs 45 pounds, and it already has 50 pounds on it from the previous lifter. So if there's already 50 pounds on this bar, we can assume that this is a 25-pound weight right here, and this is a 25-pound weight right here, because that's the 50 that's already on it, okay? So there's 45 already for the bar. The bar itself is 45, plus the 50 that's already on there from the previous lifter, plus whatever weight our new person's going to put on there has to be less than or equal to the 225 pounds that they can actually bench press. So again, the bar plus the weight that's already on there, that's already going to be 95 pounds. So then the 95 plus whatever else just has to be less than or equal to the 225 pound max that the bodybuilder can bench press. So here we're looking for all of the numbers to be less than or equal to 225. Now the way the answer choices are written, let's kind of take a look here. See how all of the numbers, all of the stuff are on this side? And then here, same thing, all the stuff's here. So let's just see which one has the alligator eating the right side, which sounds funny. But the alligator symbol eats the 225. So we want the alligator symbol that eats the 225, which is answer choice B. And it shows the 45 already on, or sorry, the bar that's 45, the 50 that's already on, plus whatever this bodybuilder chooses to put on there, just has to be less than or equal to the 225 that they can bench. You'll notice answer choices C and D don't even make sense because they don't have all of the stuff on one side, and that's why we can knock both of these out. All right, for number 5, in order to win a Girl Scout competition, Octavia is selling cookies. So far, she has sold $36 worth, and the boxes are selling for $4 each. She must sell at least $150 to win the competition. Which of the following inequalities could be used to calculate the number of boxes she must now sell to win? Well, first of all, if she must sell at least 150, that means all of the stuff that we write with all of the math needs to be more than or equal to 150. So let's look at our answer choices. We're looking for all of the stuff to be more than or equal to 150. It works for B, it does not work for C, and it does not work for D. Answer choice B is the only one that shows that all of this has to be more than or equal to the 150 for at least 150. And this shows that it's $4 per box, plus the 36 that she's already sold has to be greater than or equal to the 150 that she's trying to sell to win the competition. So when we solve this, when we subtract the $36 from the 150, let's just get a calculator up real quick. So her goal is to sell at least 150, but she's already sold $36 worth. So that means she only has 114 left over. So when we subtract the 36 on both sides, now we're saying that the $4 for each box has to make at least $114. That's how much she has left to earn. So now let's divide this by 4. And we get a decimal. So if she were to sell 28 boxes, let's do 28 boxes. That's not enough money. So she needs to sell at least 29 full boxes, because if it's 29 boxes at $4 each, she'll have earned 116, plus the 36 she's already earned. That puts her above 150. So again, we picked the inequality, and when we solve it, we rounded the decimal up because she would need to sell at least 29 full boxes to win. All right, we're almost done here. For number 7, Cher wants to buy several shirts and pairs of pants for school. So we're going to write an inequality for this, and there's not a spot for this in your notes, so you can just write it right here off to the side. So Cher has $150 to spend, so basically all of the stuff has to be less than or equal to 150. All right, so each shirt costs $7, so $7 for each shirt, and then $12 for each pair of pants, so $12 for each pair of pants. And if we knew the price, or sorry, if we since we know the price of the shirts right here is 7, and we know the price of the pants right here is 12, she can kind of guess and check to see, like, if I buy this many shirts, how much money would I have left over for pants? Or vice versa, if I bought this many pants at $12 each, how many shirts could I afford? Now this school year, we haven't done anything with solving variables if there's more than one variable, like an S and a P here. And eventually this is something you guys are going to be exploring next year in 8th grade for algebra, but I just wanted to kind of point out how that looks right now this school year. $7 for the shirts is 7S, $12 for the pants would be 12P, and all of that just needs to be less than or equal to the 150 that she has to spend. All right, and now for the last one here, number 8. Michelle and her friends are having a slumber party and they're ordering pizza. Pepperoni costs $20 each, so like a pepperoni pizza is $20, and a cheese pizza is $16. Michelle is in charge of ordering the pizzas and can spend at most $100. So which inequality represents this situation? Again, there's no spot for it right here in your notes, but you can just write it here with me. So if she can spend at most 100, we're spending less than or equal to $100. And the way we get there is that pepperoni pizza, so it's $20 for a pepperoni pizza, plus $16 for a cheese pizza, and all of that needs to be less than or equal to 100. Once again, you're kind of starting to see setups where you've got more than one variable in the same inequality. We're not going to solve anything here. I'm not telling you if she bought this many pepperonis, how many cheese did she get. We're not worrying about that. We're just trying to get comfortable with how to see that this scenario now matches, or this inequality, I should say, matches with this scenario. Okay. All right, so now you're going to practice on your own where you've got a bunch of word problems and then matching, and that's on the next page here. And that concludes today's video. Thank you for watching.